power engineer and have the exposure of working on field, on ground level, little bit on policy level, and on the construction activities also. Right now, the world and India, we have been facing an unprecedented situation. We have never seen this situation in our life, neither our ancestors have seen it, nor I believe the new progeny will see. Last 2 years, almost the world is virtually crippled. But again, with the help of technology, the positive side of that, the help of technology, we are partially crippled. Our physical movement stopped, but work really didn't come to a standstill because the thing has been made possible with virtual activities, and it has been made possible by the engineers who work on control system, the automation, the sides, the positive sides of entire control operations has really made this thing possible. Engineering and technology sides, earlier days, it was impossible to work without in hand. But today, everything is possible. Virtually everything is possible without physical movement, without going, and even taking decisions on that. Think a boiler where the coal is burning at a core temperature of say 2500 degrees centigrade. And we are to control the coal flow without going inside the boiler. How the data comes outside? How do you know that a transformer hotspot temperature is pretty high and which is corrupting the insulator without knowing the internal situation? Then how do you know that the turbine vibration is pretty high, and if it goes on like that, there will be a possibility of failure, so we can make preventive shutdowns and take corrective actions. Today, the technology has gone to that extent that without going into the machine itself, decision makings are possible only on the trend analysis and inputs available from various code information of the unit, very critical units. Now, research activities, particularly on this control and management, and on the getting information and taking decisions on time, which is really important, because getting a plethora of information which floods the brain with lot of inputs, but we do not know, and we often fumble to identify the exact reason of the problem, how and what are the real ways through which we can tackle the issue. So decision making, again, it is human dependent, perception related. So there are right now even solutions with artificial intelligence that if such type of trend do happen, and which has happened in many cases, whether it leads to a failure or it can be tolerated. So this is also being done by machines. So the area where the research work can go on is really umpteen number. From medical science, from rocket science, from defense, from normal engineering, from production, manufacturing, education, everywhere, these technology can be applied. Even the surgeries are being done through robotic surgery without physical intervention. Somebody else is teaching. Somebody else is breaking stones in a gallbladder. And after completion, it is identifying that its job is over and the units can be taken out. how this is possible. Only imagination earlier could have made it possible. In fact, when we people were born, that time television was not feasible. I have never seen television before I passed out my secondary examination. Mobile telephone was missing. Today, everything is possible through smart mobile phones. Everywhere, the control operation, the decision making, all are connected together. The IT, information technology, the sensor technology, the communication technology, the various automation technology, everything has been clubbed together and we do not know its limit. So if we want to identify that where it will end, I should say that the control engineering and the trades ultimately end if it can create an intelligent person like human being. So far we know that it has been created by God. I don't know whether we are going to overshoot God or we are being at par with it. But I must encourage that engineers should go on with their efforts till the human intelligence allows. And I encourage such activities from the core of my mind and assure you to extend all support from IET so that young minds from young boys, young girls can be more enriched, more flourished, and they can be more creative, more innovative, more constructive in doing such things in future. I will not extend much. Thank you very much for inviting me once again. And I wish all the best to the program. Thank you very much.
Thank you so much, sir, for enlightening us by your views. Now, let's welcome Mr. Shushanto Ray, Secretary of IET Local Network, who received his BE and ME degrees from Electrical Engineering Department, Jadavpur University, Kolkata, India in 2002 and 2008, respectively. Presently, he is an assistant professor in the Electrical Engineering Department, Jadavpur University. After joining Jadavpur University in 2009, he has worked as a scientist in Defense Research Development Laboratory, Hyderabad, one of the premier laboratories of DRDO India. He was a visiting professor of UPV, Spain in 2019. He received IEEE PES Outstanding Engineer Award in 2018. He is also Secretary of IET Kolkata Network and Secretary of IEEE PES Kolkata Section. His field of interest includes development of embedded systems, design of electric machines, fault analysis of electrical machines, BLDC motor drives, etc.
Thank you, Shreya, for your kind introduction. Welcome all the participants in this particular seminar and all other delegates present here. Today's topic is, as I can see that modern research or recent researches in control system. And as you know, that control system is a very important area in any engineering discipline because it's the most important subject, I should say, which is a very much interdisciplinary. Okay, so you can be you can study any sorts of engineering, but you should know some sorts of control system, not only electrical or electronics. In other discipline like mechanical also, they have very much control system. Okay, and basically the control system is used to ease our life, to give the convenience and comfort in our life. Okay, so it has application in various sectors like industries, and as Mr. Shankar Mukhopadhyay mentioned, that it has even application in surgery, in medical sciences, and it has very much applications in defense and space research. Okay, so I have some sort of experience to serve as a defense scientist, so I know that. So it can be used a lot in defense and space research. So today's topic is very much relevant, and as it is mentioned that recent researches in control system engineering. Actually, control system engineering basically it comes from the mathematics, and we use the mathematics tools to solve the different system problems. So system can be electrical, system can be electronic, system can be mechanical, anything. Okay, so basically it's the I think in your undergraduate study, whoever already third year or fourth year, they may be studying the different type of control tools like stability analysis tools like Bode plot, Nyquist plot, polar plot, etc., etc. So, and there are several tools in nonlinear domain. I think you haven't studied those. Okay, so mostly nowadays the researches are going on these nonlinear domains, and some researchers definitely is going on in linear as well. But some researchers are going on selecting different plants, different type of plants. Like I am from this electrical machines. So electrical machines can be treated as a plant for the control system, and you can use your own tools, own area of control to solve or to control a particular objective. Like suppose I want to control the speed of a machine, of a motor, we can use the control. Okay, the plant can be a power system as well, because you know that power system stabilizer, power system stabilization is a very important aspect of any power plant. So there also we have a huge application of control system. So it's very relevant area, and I should say that you have a very eminent speaker today, that Professor Rajiv today from NIT Silchar, I think. So I think you will be definitely benefited from this particular seminar. I will not extend my speech. So thank you very much again for inviting me in this inauguration. Thank you. Thank you very much.
Thank you so much, sir, for your valuable speech and kind presence. Over to you, Shreya.
Without wasting any more time, let's call Professor Shubhajit Bhaumik, who is an IET YPS chairman of Kolkata Local Network, to say a few words about the webinar.
I think sir has not joined due to some unavoidable circumstances. So you can go for the next one. Okay. So yeah.
Okay, so yes.
Okay, sir. Okay, then without further ado, let's welcome Professor Aritra Ghosh, who is the Secretary of IET YPS Section Kolkata Local Network, to talk about the webinar.
Hello, good afternoon, everyone.
Yes,
Am I audible?
Good afternoon,
Yes,
sir.
sir.
Yes, sir.
Okay, so first of all, without further ado, I will not take any more time. First of all, I would like to congratulate Mr. Niban sir and Ankit sir to create a program about the control engineering, because further in the previous section, we have already organized different kinds of workshop, seminar or webinar about Raspberry Pi or about the Arduino, about the core power system engineering. But this is the first time we have organized a program based on control engineering. So without further ado, I would like to more like to listen from Rajiv sir. So please start the program. Okay.
Thank you so much, sir, for your views in the webinar. Now, I would like to introduce our speaker of the day, Dr. Rajiv De, who is an assistant professor in the Department of Electrical Engineering, National Institute of Technology, Silchar, Assam, India. He obtained his BTech in Electrical Engineering from NER-IST, MTech in Control Engineering from IIT Kharagpur, and PhD in Control Engineering from Jadavpur University in 2001, 2007, and 2012 respectively. He was postdoctorate fellow in the Department of Automatic Control, Center of Research and Advanced Studies, Mexico City during 2015 to 2016 under the grant from TWAS, the World Academy of Science, Italy. Dr. De has more than 20 years of teaching experience and around 12 years of research experience in the area of control and applied mathematics. He has guided 4 PhD students so far. He has obtained sponsored projects from AICTE, Spark project from MHRD, Project Matrix from DST, and 4 GIAN projects from MOE. During 2018 to 2020, he was visiting faculty under Erasmus Plus program of European Union to UAV Romania. In 2020 August, he has been appointed as a visiting professor by UAV Romania to undertake collaborative research and academic activities with the university. He is a senior member of IEEE since 2013, executive member of IFAC affiliated Scientific Society, Advanced Control and Dynamic Optimization Society, fellow of the Institution of Engineers, India. Dr. De has published 6 books and research monograph with Springer. He has published 30 research articles in SCIE journals, around 16 research articles in reputed conferences, 5 book chapters, and published 1 Indian patent. His research interests include time delay control, control applications in biomedical engineering, machine learning and data science in control engineering, psychological modeling and dynamics, power system dynamics and control, and smart grid. The stage is all yours, sir.
Am I audible?
Yes, sir.
Maybe my video is not working.
Okay, sir.
I think that's fine for you all. Anyway, initial glimpse was fine. Okay, is it working?
Yes, sir.
sir.
It's visible.
Fine. Good evening to one and all here, present here.
Good evening, sir.
Thank you. IET Network of Kolkata and IEM Institute in specific for giving me an opportunity to share my expertise, or I can say my knowledge, whatever I have gained so far in the area of control engineering. So thank you, Nirban, for reaching out to me for this talk. It's nice to see you all again.
Yes, sir.
After a long break of pandemic, the life is coming to normal, hoping it will be normal in another 6 months or so. So requesting all to take vaccines so that the exponential rise of COVID, actually, if you can say the slope of the graph, if we want to slow down the slope of the graph, vaccine is very important. Please take care that you take your vaccine and try to get the slope of the graph of rise in the COVID-19 patients or infection. So we all are responsible to bring it down. And for that, we should be responsible to take the vaccine. And the first thing first is that the mathematics all started during COVID-19 to create a mathematical model of spread of COVID-19. And that's how all control system engineers were involved in creating the models. All mathematicians were involved in predicting that how the spread will be, what will be the rise of the spread, and when it will slow down, what will be the effect of vaccination after 5 years. So all these discussions that we do and comes under the purview of, again, system theory and applied mathematics, right? So just to tell you that yes, control system engineering finds its way or finds its presence in every walk of life. Maybe it is a disaster, you will find control engineers are doing their job. Maybe it's a natural disaster, you will find people are trying to take a decision, collect a data, and then try to take a decision how to mitigate the problem. You might have heard from Mr. Shankar Mukherjee that what is the importance that he has highlighted for control engineers. What are the applications where you have heard from another faculty from Jadavpur who said that control engineer is mostly like a salt in all the recipe. So if you want a taste in your recipe, you need to add some salt, and that gives you a good taste. So you cannot avoid control in any branch of engineering, not only engineering. You might have read when one of the anchor was reading my profile, you have heard that we are even trying to get into psychological modeling, relationship prediction between husband and a wife, how the dynamics of the marriage starts breaking after some amount of time. So with time, everything changes. So this universe is highly dynamical. And whenever there is a dynamics, your maths teacher have taught you, it's an ordinary differential equation that depicts the nature of any system that contains dynamics. And anywhere you find a dynamics, you can create a simple model using ordinary differential equation. If the system is highly complicated, then it will be created using nonlinear differential equation. So it depends upon how the system is complex. Your mathematical equation to represent the dynamics of the plant or the system will become complex, right? So we know that universal system or natural systems are not very simple. They are very complex, okay? There are many scientific theories and laws which governs the existence of physical system or physical phenomena. So to capture all the physical phenomena using mathematics is not a very easy task, right? And so the work of control engineers actually is very tough. So we control engineers are actually, you can say theoretician, mathematician, or engineers who work with other people of other disciplines. We work with the people from psychology, we work with the people from economics, we work with the people from biology, we work from the people from power system, we work with the people from renewable energy, robotics, and so forth, right? So we control engineers are in lookout of systems. And when we understand the system behavior, then we try to control that system. So I am told by Nirvan that most of the participants here are from undergraduate level. They are from BTech standards mostly. So I will not make my talk or discussion today evening highly mathematical, though my slides will have too many mathematics, but I will not go into the detailed discussion, just to tell you and show the ugly faces of mathematics that this generation perceives, that anything can be done without mathematics is actually not true. So we need mathematics as an engineer, as an applied scientist. We need mathematics to establish the theory and philosophy, and thereby we can design something that can give a better result for the system, or the desirable result from the system. Okay, so I will show you some ugly faces of mathematics. I know if I talk about mathematics, most of you will leave this talk. So I will not discuss in details, but yes, I will show you the effect of mathematics in our day-to-day. So with this, I will start. I think I can share my screen. I'm not very comfortable with Zoom, but I will try, and I hope you people will guide me if I cannot manage to do it. Okay, let me try.
Awesome.
It is screen sharing I must select. Is it so, or I must
Yes,
select
please.
Yes, sir.
Share screen.
share screen? Let me try. Can I do that? Can you see my screen?
Yes, sir.
Yes, sir.
Okay. What do you see at the moment?
Language.
Whiteboard.
Welcome to my talk. Can you see that?
Yes, sir.
Yes, sir.
Very good. Very good. So it means I am successful in doing the screen share. Okay. Fine.
So I'll just interrupt you for 2 minutes.
Yeah, sure.
The attendance link has been sent to you in the chat box. Please fill it up, and there will be another link given at the end of the webinar. Make sure you fill both the links to get your certificate for the webinar. Thank you, sir. You can continue.
Okay. So now you see my screen, right?
Yes, sir.
So this is our topic, today's topic. Recent research trends in control engineering. And I am not a very good orator, first thing first. And second thing, I am not very skillful in making slides. So please excuse me for these two, what you say, negative points. So these are the agenda today to give you an exposure of the trends that are going on and people around the world are working on the control engineers that they are working. Okay. So I will be going through something called artificial pancreas system, that how control engineers are involved, bilateral teleoperation, robotic teleoperation system. I will talk a little bit about fuzzy control system, which you might have studied, and time delay system and control, which is my area of research, and how to control a system which is delayed in its action. And finally, clubbing the concept of fuzzy and time delay for solving a problem of bilateral teleoperation. Just an idea that I'm going to give you. So you will see during the course of my discussion, demonstration, I will try to give you from my laboratory on telerobotics control system that we are in the process of development. I will show you a video on artificial pancreas system that is working, not in my laboratory, but from some other sources. And demonstration of time delay control in an experimental setup that was designed long ago by me and my students. So I will have two presentations lined up. One is artificial pancreas system, what is the need of engineer. So that will be my first presentation. Let me see if it works or not. Oh, it is working. That's fine. You see my screen, or you are also seeing that a screen of Zoom also coming up in between? I don't know how to adjust it.
So your presentation is.
So we can see it clearly. The presentation is visible clearly.
Okay. Okay. So we start with first presentation, that is artificial pancreas and the need of engineers. Basically control engineers and other engineers too. So don't bother about the date. Maybe it was presented somewhere else on 17th November 2019. So anyway, this is an old presentation, but still. the topic is new. So this is the outline for understanding artificial pancreas system. Definitely it's a biomedical engineering system or biomedical system. And we will discuss that how engineers or control engineers can contribute through their learning, undergraduate or postgraduate learning in control theory, how they can contribute towards this type of research. Okay. So these are my my acknowledgements to some of the people with whom I have worked in the past and still working with some. So what you will take away from my lecture is you will understand a biological system. You will try to understand a model, how a modeling mathematical model is created from the understanding of a biological system, and some control which is called LMIs in control, linear matrix inequality, sort of matrix equations if you can design, and from there if you can design a control. And certain control strategies. I don't know. Can anybody write on my screen? I think somebody is writing on my screen. Certain control strategies for the regulation of glucose in our blood. Okay. So we will discuss some control strategies. So let us first discuss what is a pancreas. Most of you know about it, and I need not describe too much about a pancreas, which is a gland present in our body performing endocrine and digestive function. So the endocrine functionality of pancreas is basically to regulate the blood sugar level by secreting the hormone insulin. Okay, so whatever food we take, that leads to the breakdown of food after digestion into glucose, or what we call it as sugar, and that sugar level appears in our blood plasma. So the utilization of sugar, or the decay of sugar in our blood is controlled by the hormone insulin. Okay, so this complex function of or interaction between the blood sugar and blood insulin is basically controlled by this gland or an organ present in our body, which is called pancreas. Okay. And then we come to something called homeostasis. It's a biomedical term. Let us try to understand this in terms of an engineer. As an engineer, how do we understand? So homeostasis means tendency to resist change of body parameter in order to maintain a stable, relatively constant internal environment. This is a definition. And in terms of engineering words, I can say that our body always try to maintain equilibrium about certain body parameters. Okay, so our body is also a mechanism. You can think any engineering system, when we talk about it, has got equilibrium. If you disturb it from equilibrium, always it will try to come back to equilibrium again. So our body exactly also has a tendency to resist the change of body parameter and maintain an equilibrium body parameter always. Okay, so this is the internal tendency and mechanism of our body to maintain the parameter at an equilibrium or a stable level. So what are the body parameters? If you go to some doctor when we are diseased or when we have some disease and we go to doctor usually tell us to do some clinical tests
and through clinical tests, they try to find out or measure the parameters or variables of our body. And by looking at those body parameters, and the doctors go for diagnosis or they go for the control of the disease. Okay, so there can be many body parameters, and one of the body parameter that we consider for artificial pancreas system is blood sugar. Okay, so there can be parameters pH, sodium, potassium, fluid balance, temperature. So many variables are albumin, HbA1c. Okay, so many parameters are available, right? So for our discussion today, the body parameter and the equilibrium of the parameter that we are talking about, in our case, it is the glucose level in the blood, or which we call it as a blood sugar. So now let us try to see the homeostasis or the tendency of our body to maintain a constant or an equilibrium level of blood sugar in our body, how it tries to do that. Let us look into the mechanism in a very simplistic sense. So you see, first in this red color, I have shown meal intake. Means when we take food, what happens? The blood sugar level in our body rises. So as soon as the blood sugar level in our body rises, in the pancreas, there are two cells that are present, which are called alpha cell and a beta cell. They are present in the pancreas. And this alpha cell and beta cell, they work just like a sensor in our body. They are biosensors. Hello? अभी मेरा एक टॉक चल रहा है, 6 बजे खत्म होगा सर. देखो. So there are two cells, or there are two sensors called alpha cell and beta cell present in our pancreas. So when the blood sugar level rises in our body after taking the meal, alpha cell stops secreting a hormone called glucagon, and beta cell starts secreting insulin. So these are automatic operations of the sensors present in our body, that one cell detects, alpha cell detects that, okay, blood sugar is going up, let me not secrete any more glucagon, or which is an hormone very close to glucose. So that stops secreting glucose in the body, and the beta cell, which is responsible for secretion of insulin, will start secreting the insulin. Okay, so one is getting stopped, one is getting started, right? And your body detects this automatically. Now what happens after this detection phase? The liver cell, the liver is an organ which works very closely with this pancreas. The liver cell now stops breaking glucagon due to decrease in glucose level. Okay, glucagon level. So what happened? Your alpha cell is not secreting glucagon, so the liver will stop releasing or breaking the glucagon into glucose into the blood. And other tissues and cells that were present in your body, okay, increases the uptake of glucose due to rising insulin. So the tissues are the cells in our body, like you have muscles, we have brain cells, we have other different types of tissues. Okay, so they, as the beta cell is secreting more and more insulin, and glucose level have also gone up, so you have to bring back the level of the glucose again to a normal position. And for that, the amount of glucose that has gone up, that has to be brought back again to a normal level. And to bring back the glucose back to a normal level, your secretion of insulin has started. So insulin now starts reacting with the glucose in your blood, and by reaction of insulin with the glucose, what happens? All your tissues, all your muscles, your brain cells, they start getting supply of glucose. Because if the tissues, muscles, brain cells does not receive glucose, it means they do not receive energy. They will stop working, right? So as soon as we feel hungry, we take food, glucose goes up, insulin starts secreting, and because of the reaction between insulin and a glucose, what happens? That your other tissues and cell in a body starts getting the supply of glucose so that they keep working, right? And in the process, what happens? Your glucose level slowly and slowly come down, because you have given a supply of glucose into the body in the form of a food, and that glucose level has, because of that, glucose has gone up. Now, because of the secretion of insulin, the glucose is being utilized by other cells and tissues of your body. Thereby, the level of the glucose comes back to a normal position again, and automatically blood sugar level gets stabilized and you get a normal blood sugar. Now let us see another scenario. If I skip taking meal, say in the morning I don't take breakfast, I just have a cup of a coffee or a tea or one bread, and I move to my office, and then I also I forget to take my lunch in time, what will happen? I am trying to skip my regular meal. So if I'm skipping meal and I'm not taking food, what will happen is that my blood sugar level will slowly go down. So the sugar level will fall. You can see in the yellow box, blood sugar level falls when you are skipping your meal. So what now detector senses, how your sensor will work now? So as the blood sugar level is coming down, the sensors in your body, alpha cell, now understands that body is deficient in glucose. So alpha cell will start secreting glucagon hormone, and beta cell will stop secreting insulin in the body. Because if the insulin secretion is not stopped in the body, then whatever residual amount of blood sugar is left in the body, that will also be utilized by the organs. And finally, when your blood sugar will become zero, a person will immediately die. So you see, our body is so wonderful. Automatic control system, you can see very clearly here. There are sensors, there are mechanisms to control the level of blood sugar in your body. So the sensor, alpha cell sensor, will start secreting glucose because it has detected the fall in the sugar, and beta cell will stop secreting the insulin automatically. And thus what happens? The liver, which stores a definite amount of glucose, right? When we take food and we receive too much of glucose in the blood, there is a mechanism that liver stores some amount of glucose into the liver for later use. So now when the glucose in the body is falling, the liver will break down glycogen into glucose, thereby releasing the glucose in the blood cells. So when the liver will release the residual or the stored glucose in the body, right? What will happen? Your blood sugar level will start rising, and then it will again go back to a normal blood sugar. So I have shown you two situations. If you skip meal, then your sugar level goes down. Body has a mechanism to bring back the sugar to a normal level. If you take meal, your blood sugar rises. The body has a mechanism, sensors and control system to lower down the blood sugar and bring it to a normal level. Okay, and this is happening because of an important organ or a gland which is called pancreas, because pancreas is fitted with two wonderful sensors, alpha cell and beta cell. What happens if your pancreas is not working properly? So if your pancreas is not working properly, now you understand two things are going to happen. One, there will be no secretion of insulin. And second, your beta cell will not secrete any insulin. And second is your beta cell will not be in a position to detect the rise in the blood sugar or the fall in a blood sugar. And because of that reason, it will also not secrete any insulin. So it means when your sensor becomes faulty, then you might have studied that it becomes something called an open loop control system. Your sensor is actually not working. Your sensor of the body is not working, and thereby the other systems in your body will also not work properly. Thereby, what is the consequence? Now you take a meal, blood sugar rises, pancreas is faulty, beta cell is not secreting insulin anymore, alpha cell is not secreting glucagon, so alpha beta cell is not working, so you don't have a closed loop condition, you have an open loop condition. So what happens? Whatever glucose is produced in the body by taking food, as insulin is not produced, so the utilization of the glucose to the other parts of the body because of insulin will not take place. Thus, sugar will always remain at an elevated level, and you will always have a higher blood sugar, and that is what is called diabetes disease. So what I was discussing so far is to make you understand that a diabetic patient has got this type of problem. Okay, so they have a problem of high blood sugar because of some problem in the gland or pancreas, or maybe the reaction between insulin and glucose, they have some problem. So similarly, you will also have a problem. Suppose you skip a meal and your blood sugar level falls. Alpha cell is not detecting anything, beta cell is not detecting anything. So again, you have an open loop condition. So liver will not be in a position to break down glucose. Thereby, there will be a continuous fall in the blood glucose level. So there will be rapid fall in the blood sugar level, and you cannot bring it to a normal level automatically. So body fails to compensate or fails to bring back the glucose level into its normal position. So I believe this type of situation you have heard in case of a diabetic patient. Okay, so they have a problem. You have seen diabetic patient keeping some type of chocolates in their pocket because they know when their blood sugar is falling and they have some problem with their body and metabolism. So they take some external glucose quickly so that blood sugar in the blood can rise promptly. Okay. So these are some experience that you may have come across in case of a diabetic patient. So this is what is the definition of diabetes mellitus. This is a medical terminology. Commonly, we call it as a simply diabetes. It's a chronic condition that occurs when blood glucose level in the body always remains elevated, remains high because of no secretion of insulin hormone or less insulin sensitivity. So there are two types of diabetes that takes place. Naturally, it happens. One is type 1 diabetes and another one is type 2 diabetes. So type 1 diabetes, তুমি সরো, এখানে ভিডিও চলে, তুমি সরো। Type 1 diabetes means when there is no insulin secretion in your body, and thereby glucose cannot be removed from the blood. So that type of disease, diabetes disease, is called type 1. And in type 1 diabetes patient, they are usually insulin dependent diabetes because they do not produce insulin in their body, and there is no secretion of insulin. So when there is no secretion of insulin, removal of glucose from the body is not possible automatically. So we have to inject insulin from an external source into the body. You may have seen insulin injections, and through insulin injections taken around that navel, so they try to inject insulin and somehow they try to control the glucose. So this type of patients are usually type 1 diabetic patient. And type 2 diabetes patient, it is a long-term metabolic disorder which is characterized by high blood sugar, insulin resistance, relatively lack of insulin production, and they are insulin independent. So most of the diabetes patients around the world, 90% are type 2 diabetes. If your parents or relatives, anybody, if they are diabetic in India, they are type 2 diabetic. They do not take insulin injections. Rather, they take medicines to control their blood sugar. It is basically there are insulin resistance. Their pancreas is producing insulin, but the reaction of insulin with the glucose for utilization of glucose is not taking place properly. Okay, so type 2 diabetic patients are mostly 90% of diabetic population of the world are type 2, and for them it is not very dangerous because it's a long-term disease. Of course, if somebody is diabetic for 40 years, maybe after 30-40 years their eye may get damaged, liver may get damaged, kidney may get damaged. So long-term complications may be there because they always have a high level of glucose in their body. That high level of glucose slowly affects other organs, but immediately there are no consequences. So in type 2 diabetes, it is more of a management of disease rather than treatment of it. But in type 1 diabetes, the pancreas is completely not working, so there is no source of insulin in the body. That is more dangerous, and in such a situation, you can say that your body is completely an open loop system. So how to make an open loop biological system a closed loop control system, and that is what is called artificial pancreas system. So artificial pancreas system is only for type 1 diabetic patient whose pancreas is completely not working. So these are some of WHO report on diabetes, and why this presentation was dated 17th November, because I was giving last year an awareness lecture on diabetes because 14th November is celebrated as World Diabetes Day. And we need to create an awareness among population that how dangerous is a diabetes disease, what are the different kinds of diabetes, and how the mechanism works. Okay, so I'm not going into it. And the medical complication from diabetes, long term, as I have said, means eye may be damaged, neuro, nephro, kidney, cardiac arrest, log amputation. These are long-term complications of a type 2 diabetic patients. And short-term complication, when your blood glucose level falls rapidly, then diabetic coma or the seizure, heart attack, or ultimate death. So short-term complication is more dangerous compared to the long-term complications. Long-term complications are because of high level of glucose in the body. Short-term complications are because of the low level of glucose in the body, below normal level if it is. And these are some terminologies: hyperglycemia and hypoglycemia. These are two important terminology. Hyperglycemia means when the glucose level in a body is always above normal. That is hyperglycemia. Hypoglycemia means when the level of glucose in the body is below normal. So if your glucose comes below normal, it is a dangerous situation. As I've said, it may cause coma or seizures. But if you have high level of glucose for longer period of time, then we may have damage of eye, damage of nerves, damage of kidney, heart, and all these. These are long term. So hyperglycemia is a long term one. Hypoglycemia, lower level of glucose, and that causes your short term complication. Basal level of insulin means the background insulin that keeps blood glucose level consistent during period of fasting. So we must have some required amount of insulin in our body to keep the glucose level consistent. Your glucose level in 24 hours should not vary too much. When we take food, it will rise. After that, it will slowly come back to steady state. You might have studied about steady state condition in control. So the amount of insulin that is required in our body to maintain a steady level of glucose, even when you are not taking food or you are skipping meal. So that background insulin or residual insulin in a body is basal insulin. And bolus insulin, bolus means, it is a slang word, bolus. Bolus means a dose of insulin that we take before we are taking a meal. You might have seen some people when they go to marriage or party, they know that they are going to take very rich food on that day. Because of that complex rich food, definitely their glucose level in a body will rise. And they know that they are diabetic in nature. To bring back that glucose to a normal level, they will take larger time. Because the body is not reacting properly to bring back the insulin, glucose level quickly to a level. So what they do, they take a injection, bolus injection of certain dose, depending upon how much food they are going to eat that night, so that that bolus injection of insulin will quickly neutralize the effect of glucose in the blood. So that is called bolus injection or bolus insulin. Basal plasma glucose. The basal plasma glucose, plasma means blood. So the basal plasma glucose defined as stable overnight blood glucose concentration. So when we take food at night and then go to sleep, so over 7 to 8 hours overnight, your glucose level should remain at a steady state. Because when you are sleeping, at that point of time, if glucose level comes below normal because of some reason, then we will never know the reason that why a patient died while he was sleeping. So your basal plasma glucose is very important. It is very important for us to know that what is my basal plasma glucose, is it a normal for my body or is it below normal for my body? So if it is below normal basal value, then we must take some precaution and we must always maintain the basal plasma glucose in our body, which is above the normal level or at least at the normal. So every person's basal insulin requirement is unique and it may change from region to region, country to country. So across the geographical boundaries, depending on the lifestyle, food habits, so this basal insulin requirement of a body are different. So am I okay? Is my speed okay, or the things are interesting or not? I don't know. Please tell me or share something. I can stop for 1 or 2 minutes. If you have any question, you can ask me, because I don't think we will have enough time later to discuss on this. Any questions? You are there? I don't know.
Yes, sir.
Yes, sir.
Things are okay, going fine. Any questions so far?
If anyone has any questions, they can type it in the chat
Yeah,
box.
because I cannot see the chat box.
And I will read it out to sir. I will read it out to you, sir. So if you people have any questions, please write them down.
Fine. So now I have talked about few terminologies. Now question is, how do we determine those levels or the concentration of glucose in our body? How much glucose do I have in my body? What is the concentration of insulin in my blood plasma? How much amount of glucose do I have in my blood plasma? Okay, so how do we know this? These are known or determined through certain glucose tests, or which is called GTT, glucose tolerance tests. So glucose tolerance test is nothing other than it indicates the nature of glucose profile of a subject, means a patient under study. So it indicates that what is the profile of glucose in your body over the time after you have taken some food or glucose. When you ingest or when you take some food or amount of glucose in your body, then what is the amount, what is the profile, what is the nature of profile of glucose rise and fall in your body, and in what time this profile is created in your body. So that graph or that profile of glucose profile after we take food is what is called glucose tolerance test. And this is one of the important diagnostic tool for doctors. So they do perform GTT to find out or to diagnose the diabetes disease. So these tests are done in two ways. One is called orally, you can do it, and another is through intravenous. Why we call it oral GTT? Oral GTT means here glucose is taken by the patient orally, and then with respect to time we measure. After every 30 minutes we measure the level of glucose in a body and create a graph or the profile, time versus glucose concentration in the blood. So the patient takes the glucose orally, so it is called oral GTT. Intravenous GTT, intravenous glucose tolerance test, is done for ICU patients. A patient who cannot take food or glucose orally. For them, glucose is injected in the veins intravenously through injections. And then after every 10-15 minutes, the concentration of glucose is measured, and then the profile is created. The graph is created. So this is the difference, major difference between oral GTT and intravenous GTT. So this is the method, clinical procedure for performing oral GTT. Okay, you must have an overnight fasting of 8 hours, blood urine sample collected, 75 milligram glucose, in 250 ml of water is given to patient. Drink in 5 minutes time. Every third minute, your blood and urine samples will be collected and the graph will be. Okay. So you see this type of experiments we do in machine and power system also to collect data. So here also we are collecting some data from the patient to create a mathematical model. So this is the glucose tolerance test, and this is the curve that after the test it is drawn, say for 2-3 patients. This is blood glucose. Unit is milligram per deciliter of blood volume. This is the unit of glucose concentration in the blood. Okay, and this is time in hours. So this is the fasting phase, and in a fasting phase, a normal where it is, this is a this red color graph is for normal patient, means who does not have a diabetes. So during fasting period, your blood glucose should be around 70 to 100 mg per deciliter, at least in Indian population. So this is in the fasting phase, it should not be below this level. So after that, at this phase, when you take orally the glucose, then slowly in 30 minutes time, you see the glucose in your blood increases. It keeps rising, but with a lesser slope. And then after 1 hour, the glucose starts coming down, right? So you see within 2 hours time, right, the glucose has risen, and then again it has come down almost to a normal level. It rises little bit again and stabilizes. So you see that at this point, this is called basal insulin. After basal blood glucose, because during fasting phase, this is the steady value that I have. And then I take orally the glucose rises, and because of the reaction between glucose hormone and insulin hormone, the glucose level comes back again to the normal level after 2.5 hours. So this profile has a time constant of around 2.5 hours. So after you give an input here, the food is an input to your body. So after you give an input or a disturbance to the system comes back to the equilibrium after 2.5 hours. So this is not an electrical system whose time constant is in seconds, but it is a biological system whose time constant is in hours. Okay. So this is the normal patient. Let us see what happens in a moderate diabetic patient. In moderate diabetic patient, in the fasting phase, basal level is high. And when that patient takes orally the glucose, the rise of glucose is steeper than this graph. So glucose rises very rapidly. In 1 hour time, you see it has reached to 250 level, crossed to 250 level. And in between, definitely insulin will be secreted from the body. And because of insulin secretion, again, it will come back. But you see, it does not come back to this position. It goes somewhere in this position, above 150, less than 200 blood glucose level. So by looking at this type of profile, a doctor can diagnose that this is a moderate case of a diabetic patient. Now let us see to the green graph. In a fasting phase, you have a very high glucose, basal level is very high. After that, somebody takes a food, it goes up. Insulin may be secreted in a body, but is not effectively secreted or not reacting with the glucose. So the rate of decrease of the glucose is very, very slow, and it cannot return even to this position. Forget about coming to the normal position of 100. So you can see that for this patient, the level of the glucose in the fasting, after fasting, or even 2 hours after taking the meal, it never comes back to equilibrium. So this is a severe case of diabetes. So this identification of diseased body and non-diseased body can be known from such experimental curve called GTT. And intravenous, as I have said, intravenous tests are done for ICU patient for many different reasons. I'm not going into it, but the clinical procedure is little different from that of oral glucose test. You can see that here injection is given intravenously within 5 minutes, this much amount of glucose. Then the counting of time will start, and the blood samples are taking 10 minutes for next 1 hour. Peak value is reached within few minutes. Why? Because you are injecting glucose directly into the veins. So it is going directly to the veins. But a person who is drinking the glucose orally, so from the stomach and the intestine, slowly it has to, through diffusion mechanism, it has to go to the blood. So there is some amount of time delay for the appearance of glucose from stomach to the blood. So the dynamics of glucose in case of oral test and the dynamics of the glucose in intravenous test will be different, because one is going directly to the blood and one is going to the stomach, and after that digestion and chemical breakdown of glucose, it will appear in the glucose. So there is a concept of definitely a time delay between these two cases. So I'm not going into it. These are some of the tests that are done. You might be knowing fasting blood sugar, random blood sugar, postprandial or PPBS test. And after doing this test, these are the ranges. If it is found, then it is used for diagnosis purposes. And I'm not going into it. These are diagnostic scenarios. Let us skip. Let me come back something to artificial pancreas system. May I know how much time do I have? Because I have to finish also quickly. I have so much of things to speak. May I know how much time I have?
So more 10 to 15 minutes.
Or 15 minutes around.
Okay. So artificial pancreas system is a technology in development, okay, to help people with type 1 diabetes, means whose pancreas is completely not working, to automatically and continuously control their blood glucose level by providing substitute endocrine functionality of a healthy pancreas. Now you see, a person's pancreas is not working. So electronically, we are trying to substitute the endocrine functionality, and that is not a very easy job. So for that, a sensor is connected here. This sensor is called continuous glucose monitoring device. It collects the glucose level, information of glucose level from your body every 5 to 10 minutes, transmit this information to this device and wirelessly, and this blood glucose information is being utilized in this device to calculate that how much amount of insulin is required for an appropriate level of glucose level at a particular moment of time. And after doing calculation of doses of an insulin, there is a tank, catheter, and insulin infusion pump. This is the insulin infusion pump, catheter, and an insulin tank, and a computer to calculate the dosage of the insulin. So based on this information, insulin dose calculation, and then injecting an appropriate amount of insulin in a body. So now what was open loop has now been closed in artificially, the loop has been closed here. So you can say that this insulin tank with the computer which calculates the dose of insulin to be injected into the body as per the level of glucose in the body being sensed is what is called artificial pancreas system. So this is wonderful. So now let me introduce that engineering component for artificial pancreas systems are a patient, There is an actuator, which is an insulin infusion pump, and a sensor, which is CGM, continuous glucose monitoring device, and the computer is none other than a control algorithm. This is where a control engineer comes into a play. So whatever control algorithm is designed can be implemented using a software or using an embedded hardware technology. So this is how the insulin pump looks like. I'm not going in details. You have seen its diagram, and this is the cross-sectional view. These are the manual, this is the infusion pump and catheter arrangement. These are the manual syringe that you might have seen. This is not used for artificial pancreas. This is how your glucose sensor works. You see your glucose sensor is sitting just above the skin, not in the veins, much away from the veins. But using this sensor, we are trying to measure what is the level of glucose in the blood flowing through the veins. Again, this is a tough exercise. So knowing the level of glucose in the blood veins from the data collected just beneath the skin is again a cumbersome process, and people are working in sensor technologies to develop such highly precision continuous glucose sensor devices. So this is glucose sensor that you have seen for manual operation. It cannot be used for your artificial pancreas. So software or computation algorithm is none other than your control design that you need to do. Because if control algorithm is not properly designed, then the proper dose calculation cannot be done. Now you see, this is a diagram which every student can understand. Now you see the complete biomedical system has been visualized as a control system. This is T1DM patient, type 1 diabetic patient. Whatever meal, stress, exercise, they are disturbance in the body. The output of interest is what is the level of blood glucose in our body. So this blood glucose is measured with the help of a sensor. Feedback, there is a basal glucose level of a body that has to be maintained for steady state glucose level. So this is the reference glucose level of the body. This is the current output. Error signal is generated. From the error signal, you will run your control algorithm, control signal, and that control signal will be given to an actuator device, or which is called insulin infusion pump, and that amount of insulin will be infused inside the T1D1 patient. So now you can see that entire phenomena of type 1 diabetic patient has been visualized as a control problem. So I'm not going into all this. Indian research scenario is there is only one project so far sanctioned for artificial pancreas, and that to IISc Bangalore, and it's in an advanced stage, because in artificial pancreas system is available in the world, but the cost is very high. Indian population at least cannot afford it, normal people. So the group working on artificial pancreas in India trying to develop an indigenous technology, make in India concept at a very low cost. So so I think I will not go into all this. I will show you a video. I will show that what work we have done. So the next thing is to create a mathematical modeling of what we have discussed so far. So I don't think I will have enough time to discuss on the mathematical models. So okay, let me just say that the entire operation can be visualized into three parts: the concentration of glucose in the blood, concentration of insulin in the blood, and concentration of insulin in interstitial tissues. So we look into the problem in the form of three compartments, where I assume that in one compartment I have a presence of glucose, in one compartment I have a presence of insulin in the blood, and in one compartment I have got insulin in the interstitial tissues. And when there are compartments and these concentrations are flowing in between these compartments with certain reaction rates, so this entire flow information, because this is none other than, you can visualize that flow of fluids from one container to another container. So when the concentration level of glucose is rising up, then the insulin concentration has also to increase. And after some time, glucose concentration will go down and insulin concentration will also eventually come to an equilibrium. So this entire mechanism can be put in terms of three differential equations, because with respect to time, the glucose will also change with respect to time in your body. Insulin concentration will also change in your body. So finally, we can write it in terms of three differential equations. Fine. So I am not going into it. So using these equations, we have tried to show that the simulation profile, which you have seen just now from OGGT model, experimental profile, it matches. You can see our model matches with the profile of those glucose profile that I have shown you a few slides back. So you see, what I am trying to show here is that I have taken some food, at this amount of food at this time. So my glucose was at 200. I have taken some food here. Then what happens? My glucose rises. And at this point of time, I have also injected some insulin. So naturally my glucose tries to come back. At this point, again, I take some food, and also some insulin is given as an injection. So what happens? Initially, the glucose rises, and again, because of the action of insulin, it tries to come back. So we can see that body is the mathematical model of a diabetic patient that we have created works fine when I am giving some amount of glucose and insulin. The glucose profile is trying to come back to its normal position, but it is not coming back fully, right? Why? Because it is an open loop condition. Under closed loop condition, we will verify that yes, it can come back to its normal position or equilibrium position. So I'm not going into all these models. I said that these are ugly faces of mathematical. So we need to do some mathematics. We need to understand some physics. I have tried to tell you about the physics, and then using the mass balance equation that you have studied in physics, using the mass of glucose, mass of insulin, and how much time it takes to react insulin and glucose. So using mass balance equation, we can create this dynamical models. So, so you see, we have tried to create a model and then test our model with some existing data of diabetic patient. So you can see this red graph matches with the profile of the patient data. So we have tried to create a new model of a diabetic patient, and then we have tried to fit our model with the data available for adolescent 001 patient. And you can see the error contained is not very high. It's almost within a tolerable range. So we could find out by doing some mathematical modeling and parameter estimation, we could show that our model can replicate the behavior of actual patients. So this is what is the trend of control engineering. The first thing first is to create a realistic model of a particular physical system. So in our case, it was a diabetic patient for which we tried to understand what is diabetes. Then by understanding the physical law that is governing between glucose and insulin, some simple mathematics we did and tried to create some set of differential equations which could capture the dynamics of a patient accurately. So we did validate our model statistically. You can see the R coefficient after fitting of graph is almost in the range of 0.9, 0.9, 0.8, 0.95. So it was a good fit, I will say. So these are some of the works done in control. I'm not going to put it. I will just play a video that this much of this, you see, these are some ugly mathematics that we'll be doing in state space. You might have studied about state space control. So this model that we have created, for which we created the state space control, we assumed the uncertainty that is prevailing in the body. These are the uncertainty in the model parameters, because body parameter may change. There is no certainty about the body parameters. So the A matrix is added with some uncertainty matrix that changes with respect to time. So we tried to create some realistic scenario in the model, and we designed some controller which is called robust controller, output feedback, and I will show you the result. This is the ugly phase of mathematics. I'm not going into it. So after doing this much of mathematics, now you see that we could achieve or bring the glucose level of a patient to a normal scenario, 80 milligram per deciliter, and that too in around 300 minutes. It has come back to a normal position. So that was possible by, so when we are designing a closed loop control system, it means that we are designing the accurate amount of insulin dose that need to be injected in the patient's body to bring the glucose level to the normal position. That is the work of artificial pancreas. Your computer must calculate how much insulin to be, you see, this is the insulin profile that we have injected, and that's how the glucose has come back to the normal level after 300 minutes. Okay, so we have done some random parameter variability. The patient parameters we have varied within plus minus 30. So whatever patient parameter was there in the model, we did not fix it to that parameter. We have varied plus minus 30% the patient parameter, and we tested our control. Now you can see in any case, the level of glucose has not gone below, maybe this is below 50, has not gone below 60, and it has not gone above 300 in any case. For this many number of patients, plus minus 30% model parameter is varying, means this many patients we have tried to simulate using our control randomly, and the controller has given a response that in any case the level of the glucose is not going below 50, which is called hypoglycemia. So we have avoided hypoglycemia, and it has not gone above 300. So hyperglycemia is also not very high. Okay, it is below 300 milligram at some point of time. So it is a well-controlled hyperglycemia and well-controlled hypoglycemia using the control that we have tried to design. So there are many controls that we have designed. We have tried even to design an insulin pump, model of an insulin pump, taking motors and plunger, piston and all that. This work I will discuss maybe at some point of time. I will quickly now show a video. I don't know how to run a video in Zoom. Let me try. That's a 4-minute video, and maybe after that I will end. I cannot complete everything in 1 hour. Let me see where it is. Okay. How to share the screen for video? Does anybody know? Please help me.
I cannot see my
So
screen.
you just switch on the video.
Switch on the video. I am switched on the
Just
video,
click
but I have to
click
share
on
it also. Is
Sir?
something like optimize something.
No, sir.
Just a minute. My video is, I don't know it's playing or not. Hold on.
So your desktop screen is showing.
Yeah, yeah. Can you see the screen? No, you cannot, I think.
Yes, so you played the video, you clicked on the video.
Yeah, but you cannot hear the sound actually.
No, it's not coming.
Can you hear the sound?
No, so there is no sound.
Can you hear the sound?
No, sir, there is no.
Yeah,
No,
yeah.
sir,
Just
there is
hold
no-
on. Hold on. That's something. You can see the screen. You can see the video, right? But not. Yeah.
Yes, sir.
Yeah.
The
Hold
video is
on.
visible.
Now you tell me.
At night, their blood glucose
Yes,
level.
audible and visible.
Yeah.
It's visible. We're also letting you know.
When night falls in Kibbutz Ma'ale HaChamisha, 18 children go to sleep, hooked up to laptops. This is the first trial of its kind. At night, their blood glucose levels will depend on these computers that function as an artificial pancreas.
דותן בן 11 וחצי ויש לי 7 שנים סכרת. עדן שעת ואני בת 12 ויש לי 4.5 שנים סכרת.
Here, 18 children with diabetes get acquainted with one another.
יש לי 13 סכרת, אני לא זוכרת, ואני די רגיל לזה. תגיד את זה ככה.
בוא נעשה ככה, יש לי 7 שנה סכרת ואני די רגיל לזה. זהו, הם נותנים יותר מדי זמן לשיחות האלה. 5 דקות זה שאלה של חצי דקה.
Dotan Yam Sirkis has been sick as long as he can remember. He's an excellent tennis player and feels like an ordinary child. Almost.
3 מקצועות בחיים. אני לא יכול להיות לו טייס של מטוס נוסעים, מטוס פרטי אני יכול, ואני לא יכול להיות נהג אוטובוס או נהג מונית. זהו, חוץ מזה, לפי מה שאני יודע, אני יכול לעשות מה שאני רק רוצה.
True, but the diabetic's path to doing whatever they want is much longer than the path of healthy children. First, there are these tests. Every few hours, they must check their blood glucose level.
רמות סוכר בדם כשהן גבוהות מדי גורמות לסיבוכים ארוכי טווח, לפגיעות בעיניים, לפגיעה בכליות ולפגיעות בגפיים. כשהסוכר נמוך מדי, חולה הסוכרת חווה סיבוכים מיידיים. הוא מאבד את ההכרה, הוא יכול לפרכס, ואפילו זה מסכן חיים.
אתם לא מתחילים לאכול לפני שהמדריך ראה מה יש לכם בצלחת ורשם את מה שיש לכם בצלחת, ושהרופא אישר לכם בולוס עליו.
Bolus in diabetic slang means another injection of insulin. In diabetics, the pancreas can't control the blood glucose levels. After a meal with carbohydrates, everyone's blood glucose rises. The diabetics must inject insulin to lower it. To gauge the amount of carbohydrates and how much insulin to inject, one must excel at math.
יש לך חישוב של כמה פחמימות זה כל לחמניה. 350. 35. זה לחמניה. תני 10 גרם.
כל פעולה שאני עושה או אוכלת, אז אני צריכה לעשות את זה לפני. אני צריכה להזריק את האינסולין ואני צריכה למדוד. זה כאילו חצי מהדברים שאני עושה, אז כזה לוקח חצי מהחיים.
The trial begins at 4 o'clock. The children enter a room with 18 laptops, and for the first time, they hook up to the artificial pancreas.
זה מרגיע. כן. שהניסוי מתחיל לעבוד.
הלבלב המלאכותי בא להחליף את הלבלב הפגוע של חולי הסוכרת.
How does it work? Two devices are hooked up to the child's body. One is the insulin pump. The other is a sensor that monitors the blood glucose levels. The artificial pancreas should link these two devices by getting data of the glucose levels from the sensor and automatically instructing the pump how much insulin to inject.
וכמה תקוות אתה תולה בניסוי הזה?
אני מתאר לעצמי שזה יצליח, זה הכל עושה לבד, אם צריך זה מזריק, אם צריך זה מונע את ההזרקות, זה הכל לבד, אנחנו לא צריכים להתעסק בזה.
אתם יכולות לדמיין שוב חיים כאלה שאתם לא מתעסקות בזה יותר?
יהיה קצת קשה להיפרד. כן, יש בזה דברים טובים גם.
מה?
קודם כל זה יותר אחריות, אז זה יותר מלמד אותך איך להיות יותר אחראי.
From now on, the children will be connected to the laptops, to their artificial pancreases at all times, even when they watch a movie.
אנחנו רואים את ההחלטות שהלבלב הזה עושה. הוא החליט להזריק פה יחידה אחת, כשרמות הסוכר מתחילות לעלות, הוא מעלה חזרה את קצב הזלפת האינסולין. כל ההחלטות האלה נעשות אוטומטית על ידי המחשב.
The system also conveys an alert when there's a problem. That's why Dr. Nimri is looking for Dotan. When Dr. Nimri finds Dotan, Eran, the trial engineer, is already with him.
החיישן בעצם איבד את המשאבה, אז אנחנו מנסים להחזיר את החיישן והמשאבה, שהחיישן והמשאבה יחזרו לתפקידם.
The malfunction is repaired and Dotan goes to his room. A phone call from home.
אבא.
היי דותן, תגיד לי איך הסוכר שלך?
הסוכר די מאוזן.
מה קורה אם אתה תהיה באמצע לילה נמוך?
הכל עולה במחשב הגדול של הרופאים בלייב.
10:30 and it's lights out. 18 artificial pancreases are now put to the test.
דותן, בסדר, 120.
The doctors and engineers are alert in the control room.
זה 73 בסנסור, אבל החיישן שהיה יותר גבוה, ניצן 76, הרן, קורא אותו זה 76.
הסוף של הפרויקט הזה זה ילדים מטופלי סכרת שלא חושבים על הסכרת שלהם. פשוט מאוד.
Yes, though Dotan, Eden, and all the other children taking part in the trial find the positive aspect, even in diabetes, they went to sleep hoping the trial will work. That one day they will wake up and no longer feel the disease known as diabetes.
So that's all from my end. There were many things to talk. But anyway, because of shortage of time, maybe I could not do it. Sorry for that, but okay, it's fine. I think it's already time. So I will stop sharing. We can take questions if you have any questions.
Yes.
There were many other things also to talk anyway.
There are a few questions in the chat box.
Yeah.
So Sumit Kumar asks, is there any permanent cure for a diabetic person?
Is there any permanent cure?
Cure, yes.
No, there is no permanent cure. I said if it is type 2 diabetes, you can manage it properly. If you manage it properly, you will remain healthy, and that is the cure, that is the treatment. And if it is type 1 diabetes, pancreas cannot be removed. You cannot remove pancreas. Ultimately, that's not the solution, because of which we are going for artificial pancreas project, but I have not heard so far. It will be wrong to say that there is no cure. But of course, medical fraternities are people are also working in this direction. Who knows, maybe one day there will be a complete cure. But as of today, I don't know that there is something called complete cure of it.
Okay, sir. So the next question is Kunal asks, how much efficient is control system technique in medical science?
It's perfectly efficient, provided your model that because most of the control system that we design and develop are based on model-based control. So we create a mathematical model of any system. So if the model is accurate, control is efficient. That is for sure. So most of our time we spent in understanding the system and thereby creating a model of it.
Okay, so the next question is from Tathagato De. He has two questions. The first one is there any non-linear estimation algorithm too for glucose level estimation, as there are certain gap between sensor and veins?
Yes. Very good question. There are a lot of nonlinear estimation algorithm to estimate the glucose level coming from the sensor. As I have said, that the sensor is placed just above the skin, which is called subcutis, and we are trying to get the information of glucose in the blood veins. So there is a gap of information or a delay. And of course, there is some amount of noise also in the system. So there are a lot of Kalman filter and its variant estimation technique that are available for doing this estimation. So these are all variants of Kalman filter. Cubature Kalman filter, extended. Extended will not work. Maybe many other nonlinear filters on estimations are available.
Okay, so and the next question is, as glucose level is dynamic, what is the dead time between the sensor to tank to body? Sensor to tank and tank to body.
Sensor to minute, around 10 minutes to 15 minutes. Actually, we are getting information from sensor to the tank at a regular interval of around 10 to 15 minutes. So around a dead time of around 10 to 15 minutes. One sample is around 10 minutes, something like that.
Okay, so and the last question is from Tanay Mondol. Is blood flow, body temperature, room humidity, do these factors affect the sensing device?
Is blood flow, body temperature, room humidity affects the sensor? Yes. Because the sensor that I have shown you, it works only for 2 to 3 days. Okay, and it works for 2 to 3 days in a particular location. You have to change the location because humidity affects the sensing mechanism. There may be some noise, and blood flow will not affect, but yes, temperature and humidity of your atmosphere will affect the sensing. Yes, of course. But definitely nowadays advanced sensing devices are coming which try to mitigate these effects. But yes, they do affect.
Okay, so that's it. We don't have any more questions.
Shreya, you can go for vote of thanks.
The second attendance link and the feedback form has been given. So kindly fill the forms up or else you will not be getting your certificates. Make sure you filled up both the attendance links. Now I would like to call upon Nirvan Chakraborty sir, member of IET YPS section of Kolkata Local Network, to give the vote of thanks.
Thank you, Shreya, for such a nice presentation. And mostly thank you, Rajiv sir, for agreeing with this proposal, for giving your time. We are hugely honored and privileged to have with you among us, sir. And I hope that the students will also get interested by hearing from you regarding the different aspects of control system, the different application of control system in different domain, not only in engineering, but you have showed us that it has a very good, a vast area of application in medical science also. So hope that the student will get interest from this and they will find their way of finding different thing in medical field also. And sir, along with us, we are very happy to share this plug with you from the IET Kolkata Local Network YPS section.
Thank you. Thank you.
For giving this speech. And thank you once again for agreeing this, sir. I hope to hear from you more in near future. And we hope that it can be done in a physical mode, in a normal mode.
Yeah, we all want it now. We are really frustrated in online mode. Really.
Yes, sir. Yes, sir.
Yeah. Thank you, Nirvan. Thank you very much. Hope you are doing good.
Yes,
and
sir.
every respect. Okay. Good.
Yes, sir.
Thank you, Nirvan.
Thank you, sir. Thank you.
Yeah. Okay. Stay safe, stay healthy, and all the best to all of you. Thank you very much. I hope I can leave now, right?
Yes, sir. Thank you so much, Rajiv.
Thank you.
Yes, sir. Thank you, sir. Thank you, sir.
So I hope you all have enjoyed the session and the amazing presentation. Fill out the feedback form and attendance form, and you can then leave the session. Thank you all for joining.